So this is the student tree distribution table where you look for the degrees of freedom and the alpha. T calculated greater than T table, reject null hypothesis. For all the tests, see, if the absolute value of T, absolute value means you ignore the mathematical sign. If the absolute value of T is greater than the critical value means the table value, you will reject the null hypothesis. If the absolute value of T is less than critical value, you fail to reject the null hypothesis. Absolute value means you will ignore the mathematical sign. Okay, so T calculated greater than T table, reject null. T calculated less than T table, fail to reject null. That's why it's confusing. So go with the P value, greater than and less than, that's all. Calculating P value manually is difficult. It can be done in system. Okay. So these are the distributions for different tests. Test is student tree distribution table. Anova is F test. F distribution. Anova is F distribution. Chi-square is chi-square distribution. Chi-square is chi-square distribution table. So you have distributions in which you have to degrees of freedom is the critical value. But for doing in Python and R, we don't need all those things. It will directly give you the p-value. We will go by the p-value. Always go with p-value only. That is the easiest way of interpretation of the test. P-value less than 0.05, reject null. P-value greater than 0.05, fail to reject null. Wherever, in whatever algorithm you will see p-value, it must be less than 0.05. In Python, you won't see p-values because Python does not stick to the statistical rules. See, the only difference between machine learning and statistical learning is statistical learning strictly sticks to assumptions. That normal distribution must be there, p-values must be this, be less than 0.05. All these statistical rules are there, which are to be strictly followed in statistical modeling. In machine learning, we use same statistical models, but we will not implement all the assumptions. Certain assumptions we will ignore. Certain assumptions we will ignore. Some assumptions we will take into consideration, but some assumptions we will ignore in machine learning. Because if you stick to statistical assumptions, you can never build a model. So what machine learning does is it borrows the statistical models, but it ignores the assumptions. Okay, so that's why there is a difference between statistical modeling and your machine learning. In case of Python ML, we don't look at, it does not give you p-values output. Nowhere it will give you the p-value as output. Now we are using scipy.stats. Scipy.stats is the statistics part of the Python. But when you go to the core machine learning of Python, which is sklearn, sklearn is the core of machine learning in Python. If you go to sklearn, it will not give you any p-values. If you go to TensorFlow and Keras deep learning, there is no concept of p-values. Whereas R, being a pure statistical software, it will give p-values for every algorithm. R is a pure statistical programming language. It is not a machine learning language. It's a statistical language. So you will get statistical outputs in R. Similarly, SAS is a pure statistical language. It will give you p-values and lot of other values, metrics, other tests. All those tests will be given in SAS. All right. So that is the broad differentiation you need to understand between statistical modeling and machine learning. All right. So in the previous class, we were doing t-test and Anova, where one variable is numerical, the other variable is categorical. But in real time, you will see both variables as categorical. Both variables. Is the font size okay, or should I increase? Okay. Both variables are non-numeric and categorical. By the way, you can open both the notebooks and then you can run all the cells. You can open both the previous notebooks and run all the cells. And you can continue in the classification notebook. I am writing the notes in the classification notebook. I'll share the notes. So before interview, just go through the notes given by me. It will be easy for you to go rather than going through websites, understanding all those things. Whatever PDF files I am giving in that notes is there, you follow that notes. That's the simplistic and easily explainable in interviews. Okay. Both variables are non-numeric and categorical. What test we will do? Chi-square test of independence. Chi-square test of independence is conducted when both the variables are non-numeric and categorical. Chi-square test of independence. The null hypothesis for this test is there is no association between both variables. Alternate hypothesis is there is association between both variables. Association means relationship. There is no association between both variables. There is association between both variables. And the interpretation is based on the p-value. So the interpretation is based on the p-value. Like how we did earlier, the same interpretation will be followed here. And then the input of chi-square test of independence is cross tabulation. This is one of the most important things to remember. The input of chi-square test of independence is cross tabulation. What is cross tabulation? Cross tabulation we have done in the last sessions is frequency table of two categorical or non-numeric variables. Is frequency table of two non-numeric categorical variables. Right? So chi-square test of independence, the input is cross tabulation. The input is cross tabulation. Cross tabulation is the frequency of table of two non-numeric variables. See, we have done cross tabulations in the top, pd.crosstab. If you remember, we have done pd.crosstab. See here, pd.crosstab between gender and churn. This is called cross tabulation. Gender and churn both are non-numeric variables. Cross tabulation. So, test null, no association between gender and churn. He is not getting the screen. I am sharing my screen. You are not able to see? I think you have to install the Zoom app on your laptop. I am sharing my screen. Just you have to open Zoom application. Restart the system and open. See, anybody logged into Zoom and just check if the screen is visible? I also send you the group link to you. Huh? The screen is not coming, huh? But I'm sharing the screen. See, now it's coming. Screen is not visible. Clearly coming? Yeah. Now it's coming, right? Yeah. It's coming? Yeah.
So that project we are not able to open. It is showing on line number one.
Which project?
In our aggregate.
You have to click .r project file. You are clicking on that .r project file. .r project you have to click. No. .r project. In that folder, you will see .r project, .rproj. Blue color R symbol will be there.
Yes, sir.
Click on it, double click on it.
That I am opening, but it's showing could not open file line number one.
No, there is no file invalid line. Okay. You are everything in one product file.
No, sir, we didn't create any project. No, sir. We just opened whatever we done in class. We just created our script.
You should not get that one file.
This is the first project we have created.
Line number one is invalid. Okay, do one thing. Open that R project file. Copy paste the text to okay. I can create a new file and copy paste the code which I sent to you. And then no problem. Input the data. Okay, so when both variables are non-numeric and categorical, we will use chi-square test of independence. The null hypothesis is no association between both variables Alternate hypothesis is there is association between both variables. The interpretation is based on the p-value. The input is the cross tabulation. So the null hypothesis which I am giving here is test null, no association between gender and churn. So let us do the cross tabulation. PD dot cross tab telco churn dollar gender telco churn dot gender comma telco churn dot churn. This is the cross tabulation. We got the cross tabulation of the values. Now we will do the chi-square test. From scipy.stats import chi2 underscore contingency. chi2 underscore contingency. chi2 underscore contingency. You can copy the cross tab command from here and paste it down. Control C and paste it in the brackets of chi2 contingency and run the values. So the second value is the p value. So fail to reject null. So this is the process of conducting the chi-square test of independence. Okay. Scroll down. Done. Test null, no association between gender, between churn and payment method. Test no association between churn and payment method. Do the cross tabulation first and then do the test. So what is your analysis? cd dot crosstab telco churn dot churn comma telco churn dot payment method. I2 underscore contingency so this is the p value. The second value is the p value. Reject null. So go to Google and type chi2 underscore contingency. You will know. Just type in Google chi2 underscore contingency. Type in Google, you will go to the documentation site. Got the documentation, chi2 underscore contingency. So return, so it will give you the first what arguments you give, returns. In the same documentation, say returns. Returns what? First chi-square statistic, second is p-value. Chi2 underscore contingency. See here, the function computes chi-square test that for the hypothesis test of independence observed and expected values. Parameters is observed, correction, lambda, chi2. So returns what? See, returns means the output. First one is the test statistic, second one is the p-value, third one is the degrees of freedom. So the documentations, whenever you get any doubt, type the function name in Google. The first link will be that link only. You will come to know the null hypothesis. You will come to know the test statistic. You will come to know the what is returned. Okay, what values are returned. You will get to know that part also. Okay. So this is your chi-square test of independence, which was done on non-numeric variables, categorical and non-numeric variables. What? That is the expected table. So what happens is, this is your actual table, right? So using the formula row total multiplied by column total divided by grand total, a expected table will be created. The expected table will be created using the formula row total multiplied by column total divided by grand total. So you'll create an exactly like this table. You'll create an exact table like this, and then sigma observed minus expected whole square divided by expected. That means this value and the expected table value will be taken into consideration and it will be deducting it. Or let me show you once. What is this? It's not coming. Give me the values. What is yes? No. What are the headers?
Bank transfer,
Bank transfer, credit card, electronic check. You give me the values.
250,
Uh,
250,
okay.
232,
Okay.
1071,
Uh,
308,
hmm.
1286, 1290, 1294, 1304.
Okay, this is the actual table. Okay. Expected table will be created. Oh, sorry. But before that, we need to have the row totals and column totals is equal to this plus this. Drag it this is equal to sum of this. And if you take this 7043, right? This is what row total. This is what column total. Okay, and this is your grand total. 7043 is your grand total. Is your grand total. So what it will do is equal to row total bracket open bracket row total multiplied by column total divided by grand total. Now, if I want to drag the formula, row total should remain constant, right? Row total will be the constant if I drag the formula horizontally. Row total is same for all the calculations. So what I will do is I will fix the row total by pressing F4, absolute cell referencing. That means that 1869 will not move. Even if we drag the formula, the column totals will change, but the row total will remain stagnant. So this is, I'll drag it to here. Oh, what happened? Oh, I have to fix the grand total also. Sorry. Row total and grand total has to be fixed, right? By F4. Got it? So if you look at this calculation, the column total is changing, but the row total and grand total are constant. Similarly, is equal to open bracket row total multiplied, row total multiplied by column total divided by grand total. Again, I will fix the row total because that is constant, and I will also fix the grand total, which is the constant, and I will drag it horizontally. If you check that output, you got the same numbers. Check the output, same numbers, right? Of Python output, you'll get the same numbers, 409.73, 403.89. You got the same numbers, right? Now, chi-statistic is equal to open two brackets observed minus expected close bracket to the power of 2 divided by expected plus open bracket observed minus expected to the power of 2 divided by expected plus observed minus expected to the power of 2 divided by expected, close bracket. No, no close bracket here. Okay, plus open bracket observed minus expected to the power of 2 divided by expected plus open bracket observed minus expected to the power of 2 divided by expected plus open bracket observed minus expected to the power of 2 divided by expected plus open bracket observed minus expected to the power of 2 divided by expected plus open bracket observed minus expected to the power of 2 divided by expected. 648 you got? Chi-statistic. Right? 648.142. Right? 648.142. Degrees of freedom. Number of rows minus 1 multiplied by number of columns minus 1. So how many rows are there? 2 rows minus 1 into how many columns are there? 1, 2, 3, 4. 4 minus 1. 3. You got degrees of freedom as 3. Just check. 3. Degrees of freedom is 3. Degrees of freedom is 3. Now, p-value. P-value is equal to chi-dist x, comma, degrees of freedom. 3.628 E4. You got the same value? Exactly the same value. You get it in. I think there's a chi-test. Actually, we need to not to do these things. You can directly give chi-test. Chi-square test. This is the actual range. Don't select the totals, comma, the expected range. It will directly give the p-value. Same thing. So understood, right? The calculation of how the chi-square test is done. So the values are expected table values using the formula row total multiplied by column total divided by grand total. Okay. Now, there is one more test. There is one more test called paid sample t-test, or also called as related sample t-test. Paid sample t-test or related sample t-test. Here, the data will be in form of before and after. That means data comes from one entity at two different time intervals. At two different time intervals. Take, for example, the blood pressure of the patient before taking the tablet, the blood pressure of the same patient after taking the tablet. Right? The amount of sales before doing the advertising campaign, the amount of sales after doing the advertising campaign. So before and after, your data will come from same entity, but at two different time intervals. Before an event, after an event. That we call it as paid sample t-test or related sample t-test. Okay. The null hypothesis is same. There is no significant difference in average whatever variable before and after. Before and after. So you copy the same statement down, convert null to alternate, and remove the word no before significant. There is significant difference in average variable before and after. So this is called paid sample t-test. The inference is again based on p-value. The inference is based on the p-value. The inference is based on the p-value. Okay, so test null, the average monthly inflation before and after demonetization is equal. You all remember 2016 November, there was demonetization in India. So we want to know whether the demonetization have affected the inflation. So the monthly inflation before demon, what was the monthly inflation? Before demonetization, the inflation was 3.35, 4.14, 5.30, 6.46, 6.13, 6.59, 5.86, 5.51, 5.53. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5.53, 5.91. So 3.35, 4.14, 5.30, 6.46, 6.13, 6.59, 5.86, 5.51, 5.53, 5.91. How many are these values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will go to 2015 also. Okay. 6.32 and 6.72. So this is the before demonetization. After demonetization, what was the monthly inflation? $2.59, 2.23. Then we'll go to 2017. 1.86, 2.62, 2.61, 2.21, 1.09, 1.08, 1.79, 2.52, 2.89, 3.24. So these are the values before and after. Okay, print np.mean before daemon, print np.mean after daemon. We will check the mean difference. Okay, null is there is no significant difference in average inflation before and after demonetization. Same statement you can copy and paste as alternate and remove the word no. That's all. From scipy.stats import t-test underscore related, t-test underscore rel. T-test underscore rel. So t-test underscore rel before daemon, comma, after daemon. But reject null. Since p value is less than 0.05, we will reject the null. T-test underscore related and t-test underscore independent. The earlier one was independent, this is related. Because we are using the same CPI inflation before and after. Got it, all of you? Test null, the average monthly inflation before and after GST implementation equal. So GST was implemented in India in July 2017. So before GST implementation, the tax implementation, what was the monthly inflation? It is 1.08, 1.09, 2.21, 2.61, 2.62, 1.86, 2.23, 2.59, 3.35, 4.14, 5.30, 6.46. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After GST is equal to, after GST implementation, $1.79, 2.52, 2.89, 3.24, 3.97, 4, 5.11, 4.74, 4.36, 3.97, 3.96, and 3.93. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For GST and after GST. So null is, there is no significant difference in average inflation before and after GST implementation. There is significant difference in average implementation. T-test underscore related before GST, after GST. Oh, I didn't find the mean difference, sorry. Print np dot mean before GST, print np dot mean after GST. So 2.96 and 3.70. p-value is greater than 0.05, fail to inject null. So monthly GST before and after implementation, GST implementation.
So what is the command name for t-test related? For what is that?
Paired is equal to true. T dot test. We do T dot test, huh?
Yes.
Same T dot test function. You have to add an additional argument, comma, paired is equal to true. PAIRED.
T dot test, comma.
No. T dot test, give the data references.
Yes.
Before GST, after GST, comma, paired is equal to true. PAIRED, small letters. Paired is equal to true. T, capital T. Capital T, just give capital T. You will get the same output. Check the T statistic, 0.116, sorry, 1.70. Yeah, you will get the same value test. So same T test, add additional argument, paired is equal to true. Related. Paired is equal to false is independent.
Instead normal t dot test.
Normal T dot test. Wells to sample T test. Chi-square test you are able to run? Chi-square test same.
No.
Chi-square test also, see chi-square dot test. And you can run, you can give direct to variable names by what you call telcochan dollar variable 1, comma telcochan, comma variable 2, you will get the chi-square test also.
So for chi-square, they have to do the cross tabs.
Yeah, you can give cross tabulation or you can give directly.
Directly.
Directly also can give in R. So chi-square test in R, you can open the last class R studio file. So what was this? Test null, no association between churn and gender, right? No association between churn and gender. So cross tabulation is table telco churn dollar churn, comma telco churn dollar gender. Cross tabulation, right? The test is chi-square dot test telco churn dollar churn, comma telco churn dollar gender. 0.48.
So we will use some
Why? We're getting different p-value. What was the value you got?
Sir, in Python 3.68 into 10 to the
No. X square, how much you got? Chi-statistic.
Statistics is 48.1.
No. We got 0.48 here. Oh. Table. telco churn dollar churn telco churn dollar gender, right? Gender and churn.
Sir, I did for payment.
No, what we did in Python, first one was churn and gender, right? 0.48, correct only, right? Then we did for churn. So, that's null, no association between churn and payment method. So you can see table telco churn dollar churn comma telco churn dollar payment method. Okay, we got the same table. Chi-square.test telco churn dollar churn comma telco churn dollar payment method. .18. P-value is the lowest p-value R can give. Python will give you the actual p-value, but there is a limit on p-values in R. The lowest p-value R can generate is 2.2 E minus 6. So these are the chi-square tests in Python. No, sorry, in R.
Sir, here regulation is not
Huh?
directly we are getting.
Which one?
Means
Cross tabulation will do it in the backend. In R, it will do it in backend. In R, it will do it in backend. So you need not worry about that part. You have done that vaccine example. Which is that vaccine example? That are
Sir, one in LMS one vaccination data set.
that one. Okay.
It's a categorical direction.
Yeah, actually, that's in driven data. H1N1 vaccination is a seasonal flu vaccination.
Whether the person
Two dependent variables will be there.
whether the person got the vaccine or not.
Missing
Going
value.
to take the vaccine or not.
So missing values you have not done there.
No.
But there are a lot of missing values, no, in that one.
In HML, no. Yes, yes. In that data set, we have mentioned.
What did you do with the missing values? Deleted them, huh?
No, sir. By using mode method.
Okay.
And mice.
Nice.
But that complete imputation I didn't get, sir. Till now. How to exactly.
We'll do that.
Yes,
So you have to reduce, you have to reduce the iterations, and instead of RF, you have to use PMM, predictive mean matching. The imputation method, instead of random forest, you should use PMM first, predictive mean matching. But if predictive mean matching is also giving you memory error, then the second method is CART, classification and regression tree method you have to use, CART and so CART technique is nothing but decision tree. It uses decision tree to impute. But you need to reduce the iteration, and m is equal to 2, iteration is equal to 2. You have to make it 2.
I gave them equal to 5.
No, don't give 5. 5, your laptop, what is your RAM? 8 GB, 5 will work, but 4 GB, 6 GB, 5 will not work.
But in next, I got that m equal to 5 is the minimum.
That is default. That is default. Okay. You can reduce it. So preferably m is equal to 2.
Means 2 data set will be there.
No. It will try 2 iterations, 2 imputation types. So we'll get only, end of the day, we'll get only 1 data set.
End of the, after imputation,
we will get only 1 data set.
2 imputation.
No. That is not the process.
You have to choose from that.
No. It's not like that. So it will try all the methods and it will give you the best. All iterations and all methods it will try, and it will finally complete function will give you the best with the least RMSE or least accuracy. Highest accuracy will be the best method. So in R you can do it easily. In Python it's still a problem. Python we can only use simple imputer. Iterative imputer, maybe next version it will come.
So sometimes the data set get imbalanced.
We will talk about balanced methods. We have a complete session on balanced, all methods, both R and Python. All methods will be discussed. That's an exclusive session. We'll do it at later stage. Done. All of you are done with R. Copy paste that paid sample t-test data also into R. Paid sample t-test. You have to change them into vectors. The square brackets have to be changed to vectors. You have to change it into vectors. Okay. Before GST, after GST. T.test, same thing, before GST, comma, after GST, comma, paid is equal to 3. So paid t-test, you get the same as 0.11 minus 1.7013.
In paired, one numerical and categorical.
2 time frames, before and after, that's all. The data will be in 2 vectors. Table will be, data will be in 2 vectors or 2 arrays. One before array, one after array. You will have only 2 columns of data, before and after. Oh, we didn't do the mean also here. We have to do the mean, right? Mean for GST. After GST. Before and after mean, and then we do the test, mean difference, and then the test. So all of you log into Analytics Vidya. There's a practice problem called Big Mart Sales. Register to that competition, download the data sets, train file, test file, and sample submission file. Create a folder and save them all three in a folder in your Python default folder. Analytics Vidya, Big Mart Sales. Use your Gmail, Google ID to log in. Then R is done, all of you. Yeah. So Analytics Vidya, Big Mart Sales. There is this, go to Analytics Vidya, participate in a hackathon, participate now, and then you will see Big Mart Sales practice problem. Big Mart Sales practice problem, click on participate. It will ask for registered ID, Google ID, you can use your Google ID to register. Once you registered, you'll get the problem statement. Within problem statement, if you go to the end, you will see three files: the train file, the test file, and sample submission file. All three files you have to download. Problem statement. After you register into the competition, you will get access to problem statement. In the problem statement, you will have the description of the problem and then the data dictionary. What is each variable, talks of what is the definition of each variable. And then if you go to the end, you will see three files: train file, test file, and sample submission file.
Sir, in hackathon,
Participate in a hackathon.
participate now.
Participate now. Participate now. Second one, after loan prediction problem, you have Big Mart sales.
Yes, sir.
Click on it, register.
Participate.
You can use your Gmail to register. And then in the problem statement section at the bottom, you will see three files. And sample submission file, three. All three files, you create a folder in the Python default folder and save it. See, train file is complete data with dependent variable. Test file is data without dependent variables. Train file is the complete data with the dependent variable. Test file, there will be one column short or one variable short, which is the dependent variable will not be there. Build model on train data and use the trained model to predict on test data. So, train file will have all the variables, including your dependent variable. Test file will not have the dependent variable, will have all the remaining variables. You have to build a model on train data and use the train data model to predict on test data. Once you get the predicted values, copy and paste those predicted values in the sample submission file, and you can upload into the competition site to check your rank and score. So once you have predicted on test data, the predicted values are copied into sample submission file, and this sample submission file will be, there is a solution checker also. You can see if you scroll onto the top, next to problem statement, you will see solution checker. So here, if you upload your submission file, you will get your rank and score. It will tell you how close your model is to predicting these things. You will get the rank and score. So accordingly, we will understand how the rank and scores are changed based on different methodologies and all. We will study them. So this is a interesting problem we generally use for data pre-processing because it covers a lot of pre-processing methods. Okay. So all of you go to Analytics Vidya, Big Mart sales prediction problem, download all the three files, train file, test file, and sample submission file, save them into a folder and keep the folder in your Python working directory or whatever you have set up in the Python last time, you do it. People who don't do it, upload them into Jupyter Notebook, train and test file only. Sample submission need not be uploaded. Upload, train and test in the Jupyter home page, and then we will import them. We'll do. This is a complete example of pre-processing. Pre-processing is a very large subject. So all of you are doing this. Okay. So we'll create a new notebook. We can close the classification notebook and the regression notebook. I'll create a new Jupyter notebook. Create a new Jupyter notebook. Okay. No need to import data right now. I'll tell you when to import the data. First, let us look at the theory of data preprocessing. So shall I continue all of you with data preprocessing theory? Okay. So data preprocessing, some people call it as feature engineering also. Some people call it as feature engineering or data preprocessing. Under data preprocessing, there are multiple tasks to be done. The first part, the first task is check for duplicate variables or columns. You have to check for duplicate variables or columns. Whenever you import, you print the column names and see if there are any duplicate variables or columns. Second, check for single value columns. Single value columns means the whole column will have only single value. That means all the values in the column might be 0. All the values in the column might be ones. 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, or you will have a single value in those columns, repeating for all the cells in the data. So you have to identify them and you have to delete them. First, you need to check for duplicate variables or duplicate columns. Then you check for single value columns. How do we identify the single value columns? When you do summary or describe, when you do describe in Python, the min is equal to 0, max is equal to 0, mean is equal to 0, median is equal to 0. So if all the values are 0 or ones, suppose if the column is all having all ones, it will be min is equal to 1, max is equal to 1, mean is equal to 1, and median is equal to 1. So when you have this situation where in describe your min and max are same, that means it's a single value column. You have to delete it. Single value columns are of no use. You have to delete it. In SQL, even today, single value columns come up because they act as counts. They are created as count values. So employee number, then they'll add a count column 1, 1, 1, and then they do the sum of all ones, and then they'll say total number of employees. That is why you'll still get single value columns in data. So duplicate columns, you have to delete them. Single value columns, you have to delete them. Then third, missing value imputations. Missing value imputation to be done only if less than 70% of, okay, sorry, if at least 70% of the column data available. If there is at least 70% of the column data available, then you will start imputing. Suppose 90% of the column data is missing, only 10% data you have. You should not impute it. Keep the 90% as missing. Okay. So if a variable has greater than 70% missing values, impute with words like missing or not available. So if a column has lot of missing values, 90%, 95%, 80% missing values are there, do not impute, rather impute with the word missing. Keep it as missing only, or keep it as not available. If you have at least 70% data available in that particular column, then you can go and do the imputations. All right. So this first you see how much of the percent is missing. That is first one, how much you have to check. How much of the percent missing values to the total data. That's why we calculate the percentages also to check how much of the percent of the data is missing. Okay, if large amounts of data is missing, please do not impute it. Use the word missing or not available. If ample data is available in the column, if you think you can use that existing data to impute, then you can impute. Now, if it is a numeric variable, what will you do? If it is a numeric variable, you will do either mean or median imputation. Median if mean is distorted. If mean is distorted, use median imputation. If it is categorical variable, categorical or non-numeric variable, what will you do? Most frequent or mode imputation. We will do most frequent or mode imputation will be done. These are manual methods, which I am talking about are manual methods. Numeric imputation or categorical or non-numeric imputations are manual methods. Okay. Then we also have algorithm-based imputations. Algorithm-based imputation. The first one is multivariate imputation using chained equations. We call it as mice. Multivariate imputation using chained equations. We call it as mice. It imputes both numeric and categorical and non-numeric simultaneously. Simultaneously, it will impute both numeric as well as non-numeric imputation. For numeric imputation, it uses linear regression. For non-numeric imputation, it uses either binary logistic regression or multinomial logistic regression. Chained equation means first it will impute all the missing values with mean or mode. Then it will create a linear regression model with the missing variable as dependent variable. The missing value variable will become the dependent variable and rest of the variables will be taken as independent variables. And in multiple linear regression, you get predicted values, right? Once you get the predicted values will be replaced with the mean. The predicted value will be replaced in place of the initial mean. Similarly, once you do binary logistic regression, you will get the predicted class. That predicted class will be imputed in place of the earlier mode. That we call it as chained equations. So it will create equations like this for the missing value variables as dependent variable and then builds models. Okay. The second method, which is popular, is tree-based imputation methods, which is your cart or decision tree or random forest. Random forest or decision tree can be used for imputation also. Tree-based imputation methods. Then K nearest neighbor imputation method. K nearest neighbors, or also called as KNN imputer. This is also one of the algorithm-based imputation. It will take the nearest 5 observations and then uses them, calculates the distance between those nearest 5 observations. The closest will be the imputed value. So KNN is a distance-based method. Euclidean distance. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. So it uses the Euclidean distance, calculates the distance between the missing value and the closest 5 observations, and that nearest, the most nearest or the least distance value will be imputed. Then we also have something called probabilistic PCA. Probabilistic principal component analysis. Principal component analysis also is a distance-based method. PCA method is also one of the imputation methods. So this is the theory of imputation, which you need to remember. Now, the theory says you can list-wise deleting, pair-wise deleting, all those things are there. Na? You can delete the whole row. You can delete the whole column. But you can do so when you have ample data available. And clients will not agree to deletion. Why? Because data is cost. They are investing on database, they are investing on capturing the data point, and you simply go and tell this is a waste, we will delete it. That means the database guy, they are all making a mistake, which they will never accept. So the client will simply insist, no, you have to include that variable, do something with it, but include it. Because data is cost. For companies, data is cost. They have to invest on database, they have to invest on collection methodologies, they have to invest on sensors. Lot of investment goes in collecting of data and storing of data. And if you simply go and say, I'll delete these variables, the clients will simply say no. So in theory, we have that pair-wise deletions, list-wise deletions. You can delete the complete row, you can delete the complete column. No, those deletions in real time will not happen. You have to find a way to either impute them or replacing with a single word called missing or not available. Always think that data is cost. And if you are saying the client that you are making an unnecessary cost, that will have ramifications, right? If the top management knows that you are collecting unnecessary data, then there will be a big fight. Who designed the database, why this data is unnecessarily be collected, why the data analyst is saying not required, then it becomes a big issue. So avoid suggesting deletions until unless if client also comes and says, okay, let us ignore or delete this variable, or let us ignore the variable for the time being and then build the model. So deletion of variable is a complication process because cost is involved in collection and storing. It's not free, right? Collection and storing is not free, it is a cost. And companies have to bear that cost. Okay, so it's 11 o'clock. Let's take a 15 minutes break and we'll continue with the data preprocessing theory. Pause the recording. All right, we'll start. So any doubts in missing value imputation? Missing value imputations. Any doubts? So we will implement all these methods, all algorithm methods most probably in R, because Python algorithm methods little bit problems are there. Maybe next version of sklearn it may be done, but now it's not that easy to implement algorithms in Python. There are libraries, fancy impute is there, and the libraries are there, but R is best suited for imputation. Okay. Now, after imputation, data transformation. Data transformation is a very critical process. Both we have to sometimes transform dependent variable and independent variables have to be transformed. Dependent variables and independent variables. For dependent variable, if skewness is there, you will transform if the dependent variable has skewness. Remember, if it is positive skewness, what will you do? Yes, we will do logarithmic transformation or square root transformation. Okay, and if it is negative skewness, exponential. Opposite of logarithm is exponential transformation and or power transformation to the power of. Okay. This is the data transformation which needs to be done on dependent variable. For independent variables, there is a different methodology. independent variables, we have two methods. First one, standard scaling. Standard scaling or standard scaler, or also called as standardization. Standard scaling or standardization. What is this? What is the formula of standard scaler? X minus mean divided by standard deviation. You will calculate Z scores, which is nothing but Z scores. You will calculate the Z scores and then you will replace the actual values with the Z scores. That process we call it as standardization or standard scaling. The second method is normalization, or also called as min-max scaling. Normalization or min-max scaling, which is x minus x min divided by x max minus x min. Normalization or min-max scaling will scale all values in range of 0 and 1, and there will be no negative values. There will be no negative values. Whereas in standard scaling, you will have negative values and the scale will be larger. Sometimes -5 to +5, -3 to +3, that will happen in standard scaling. Whereas in normalization or min-max scaling, the scaling will be between 0 and 1, 0 and 1 with them. And all the values will be positive. All the values will be positive. Normalization. Normalization is the most preferred technique in image processing. In image processing, normalization must be done. Now, standardization will be done. Standard scaling will be done when independent variables are in different mathematical units. When independent variables are in different mathematical units. That means some variables are in tens, some variables are in hundreds, some variables are in thousands, some variables are in lakhs. Take for example, house. The price of house will be in lakhs. The size of the house in thousands of square feet, right? The size of the balcony will be in tens of square feet. The size of the hall will be hundreds of square feet. The parking space will be 100 square feet or something like that. Number of bathrooms will be 1 or 2. You will have discrete numbers. So in a data, you have a discrete number, you have a value in tens, you have a value in hundreds, you have a value in thousands, and you have a value in lakhs. When you have different mathematical units, you must scale your data. You must scale your data so that all of them will become in one single range. Otherwise, linear regression is biased to larger values. Why do we need to scale? Because particularly in regression, multiple linear regression and binary logistic regression, there will be a bias towards larger values. There will be less bias to smaller values. To avoid that bias which is there in linear regression, multiple linear regression, we must scale our data. Decision tree, random forest, they don't have this bias problem. The bias problem towards larger numbers comes only in multiple linear regression and binary logistic regression. So when you are using MLR or logistic regression or regularization methods, ఏంటమ్మా తీసుంచే మాకు గాలి రావట్లేదు, నేను అందుకనే ఇద్దని చెప్పింది. వాళ్ళకి చెప్పిన గాలి రావట్లేదు అని చెప్పింది, తీసుంచే. So you have to scale. You have to scale the data. When different mathematical units are there. Now, what is its effect on algorithm? There will be marginal increase or decrease in the values. Otherwise, it will be same. Marginal increase or decrease will be there. Otherwise, not a big impact on the performance of the algorithm. But sometimes that marginal improvement is also a very, very big improvement. Sometimes that marginal improvement also will be a very big improvement. So that is all about your data transformation, which you need to be done. Data transformation has to be done according to your requirement. Clear? Then the fifth one is dummy encoding of non-numeric categorical data. Dummy encoding or assigning numerical identifiers. Assigning numeric identifiers to categorical levels. Dummy encoding of non-numerical categorical data. In R, we will convert them into factors. In Python, we have two processes. We have two methods in Python, like I told you, label encoder, which encodes the data in single column and assigns numeric identifiers from 0 in alphabetical order. Not the frequency order, it uses the alphabetical order to encode in single column. It will not create new columns. It will do the encoding in single column. That is label encoder. Then you have something called pd.get_dummies. Now this will create new columns based on number of levels in categorical data and uses binary encoding, which is no being 0 and yes being 1. The other day showed you know how gender 1 2 1 2 and then gender underscore m, gender underscore female, two columns are created. So pd.get_dummies will create new columns and it uses binary encoding, no is 0, yes is 1. This must be done. There should not be a single value of text when you are sending the data to algorithm. If a single text is available, is present anywhere in your data, the algorithm will simply fail and say character or object type is found, and it will stop running the algorithm. So before you send the data to algorithm, there should not be a single alphabetical data or text data in your whole data frame. Okay, so dummy encoding is an important aspect of pre-processing. Then correcting duplicate levels. In categorical data. So what happens is sometimes due to data entry error, the same level will be represented. Take for example gender. Capital M is there, small m is there, MALE, small MALE is there, capital MALE is there, all caps MALE is there. So when you are inputting data like this, Python will create 5 different levels. It will treat each of them as different level. But actually what they are representing? Name. That sort of duplicating levels you will find in categorical. So we always run frequency command on categoricals to check if there are any duplicate levels are there. If there are duplicate levels, we need to correct them. That is also part of your pre-processing techniques. 7. Create new variables from existing variables. So you can create new variables from existing variables. Take for example, you can convert a numeric variable into categorical like high, medium, low. You can convert the numeric variable. If at all numeric variable is not giving you any information and you feel that is a very important variable to be included in the model, the only option is you need to convert the numeric variable into a categorical variable based on conditional statement if high, medium, and low. 3 categories, 4 categories, or 5 categories you have to do. 8. Reduce the number of levels in categorical variable. Sometimes you will see in categorical level variables too many levels, 50, 60, 70 levels. When you have more than 50 levels in a categorical variable, the algorithm will obviously take time and there is a chances of it becoming failure. So what we will do is the small categories, you can combine them into others or miscellaneous. Small categories will be there, right? It can be combined, they can be combined into others or they can be combined into miscellaneous. Thereby, we will be reducing the levels. Or particularly in geographical states, 50 states are there. So what we will do, we'll come back, we will convert them into north, south, east, and west regions. Thereby, you are reducing the variables levels. So that sort of reduction of levels must be done. Then we also have to do sometimes extract information like year, month, quarter, week from date variable. Sometimes date variable is only relevant in time series data. In time series data, date is relevant. But if you have a multivariate data set and date variable is there, what we can do is you can extract information from date like year, month, week, weekday. Weekday also can be extracted. Weekday. You can also extract holidays. If there is a holiday list, you can say whether it is a holiday or not. You can extract season from date variable. So then once you extract these variables, you will remove the date column and then you will do it. Or you can also calculate age if you have 2 dates. If you have calculate difference between 2 dates. If you have 2 dates in the column, take for example loan data, loan applied date and loan approved date. We can calculate the difference of these. You will know how many days they are taking to approve the loan. Then we will remove both the date columns. So before removing date column, you have to check whether you can extract any information from that particular date column. Date will be year, month, quarter, week, weekday, holiday, all these things can be. You can even extract is month beginning, is month end, is quarter beginning, is quarter end, is year beginning or is year end also can be extracted. So all these things can be extracted from date. Then extract codes from alphanumeric identifiers. Particularly in retail data, we find this. Alphanumeric IDs will be there. Generally, what we will do with IDs, we will delete them, right? Before deleting alphanumeric IDs, can we extract some information from those alphanumeric IDs, like product categories or product codes, right? In creation of identifiers in retail and other categories, they insert the product code in the identifier, alphanumeric. Both alphabets and numerics will be there. If you will try to find out, any codes can be extracted from those alphanumeric identifiers. The 11th one is variable selection or feature selection. So this is also important. Should we include all the variables or should we delete certain variables? You can do simple correlation analysis. Multicollinear variables can be removed. Or if the correlation is 0 or close to 0, you can remove them. But if you think even though correlation is 0, if you think it's a significant variable, you can retain it. So variable selection or feature selection, there are many methods. One is through correlation and covariance. You can decide which variables to be included and which variables can be removed. Second, based on your domain expertise, based on your subject knowledge, you can decide to include or exclude variables, or you can use algorithms. Chi-square method is there. Select k-best method is also there. That will also help you to identify critical variables. Or you can implement tree-based models. In all tree-based models, you will get variable importance as part of output. All tree-based models, decision tree, random forest, gradient boosting, extra tree classifiers or boosted trees, any trees will give you variable importance. From variable importance, you can select the variables. You have regularization methods like lasso, which will help you to reduce the variables. You have dimensionality reduction techniques like principal component analysis to reduce the variables. So variable or feature selection can be done by using many methods. One, covariance and correlation. Covariance and correlation. We can also use dimensionality reduction techniques. So these dimensionality reduction techniques will not delete variables, will combine the variables based on similarity. Principal component analysis, PCA. What it will do is it will not delete variables. It will combine the variables based on similarities into components. Then you have feature selection methods like select, what is the method name? I forgot. Select k best. Select features according to k highest scores. So the select k best method is also there, which will help you to identify critical variables. It uses chi-square and other methods. So chi-square based selection is also there. Anova based selection methods are there. So select k best. Select k best methods are there. Based on Anova, based on chi-square will help you to. Then you have penalized regression like lasso. You have tree-based models that provide variable importance. That will provide variable importance. So these are the methods which you can use for selecting variables. Particularly when you have large variables, large number of variables, you need to do variable selection.
For numerical, that covariance and correlation can be done. But for categorical,
Chi-square. Chi-square, no, same relationship. What is null and alternate? No association, or no relation, and same thing. For both numerics, covariance and correlation, both categorical, chi-square. So I am just giving you most common methods. Based on a problem statement, you will find a lot of other data preprocessing issues also. Sometimes sometimes you need to extract web scraping, you have to scrape from particular websites, or you have to scrape data from PDF documents. Then preprocessing is different. Removing punctuations, removing special characters, removing white spaces. A lot of things will be there. At the time of text mining, I will talk about that one. So text mining has different variable selection methods. Image processing has its own variable selection methods. So for a normal multivariate data, these are the common variable pre-processing methods we need to do. Okay. So these are the steps, pre-processing steps. Data pre-processing or feature engineering. Okay. So I'll set my directory, import IO, %cd, where my big mart cells, wherever you have your big mart cells now, I told you to store the path in text file. You can copy paste from your text file. So my data is in hackathons. Hackathons, Big Mart sales. Okay, get info. I'll copy the path. Folder name identifier. Hackathon, Big Mart sales slash okay, I have things. So Big Mart train. Big Mart train is equal to pd dot read underscore csv open quotes Control C. Oh, sorry, I forgot to import the libraries. Import pandas as PD. Import numpy as np. Import matplotlib dot pyplot as plt. Percentage matplotlib inline. And I have imported the train file. We'll also import the test file. Big Mart test is equal to pd dot read underscore csv open brackets double quotes test file. So set the folder path and then import the train and test file. For people who are not able to set, upload them into your Jupyter Node homepage and then call them. So print Big Mart train dot shape print Big Mart test dot shape. So you have 12 variables in train data, 11 variables in test data. The one variable which is not there is the dependent variable. All of you imported? All right. So if you look at both the data frames, sigma train dot columns, sigma test dot columns. Okay, so if you look at these things, only thing is item outlet sales, which is the dependent variable, is not there in the test data set. Item outlet sales, which is the dependent variable, is not there in test data set, which we need to predict. Rest of all 11 columns are there in the test data. Only the column that is missing is the dependent variable, which we need to predict. Okay. Item outlet sales is the dependent variable. Now, both the data frames generally in competition sites need a lot of pre-processing to be done. And whatever pre-processing you're doing on trained data, same thing must be done on test data. You can't have two different processing methodologies. The same processing methodology which you are implementing on train must be done on test. So what we should do is we should combine the data frames first and then do the pre-processing, so that we don't do differential data pre-processing. To avoid that, we need to combine the data frames into one. So you can do concatenation of data frames you can do. But for concatenation of data frames, the number of columns should be equal. But we have unequal columns. So what we will do is we will add the dependent variable to the test data and fill that column with the word test. Okay, we'll add a column to our test data, and in that we will fill the value as test. All the cells will have test, so that we can use it as a conditional format, conditional statement to separate the data back to train and test. Equal to test, not equal to test will be separated as train and test data. But the fundamental is for concatenation of data frames, the number of variables must be equal. The sequencing of the variables must also be the same. The variable sequence must also be the same. Sometimes in real-time data set, you might have to alter the variable sequencing so that you have to make both the data frames have similar columns in similar position. If you look at our data, we have similar columns in similar position. So we don't need to do it. But sometimes in real-time data sets, you have to sequence the columns, and test also you have to sequencing in the same way so that you can have the same column names in the both this thing. Otherwise, you can't do concatenation. Concatenation means row-wise concatenation can be done, column-wise concatenation can be done. So row-wise means first it will paste the rows of whatever you are specifying first, and second it will paste the rows of whatever you are specifying as second variable. Okay, so that you can do. So you can add column to the what you call additional column to the test data and do it, or you can drop the dependent variable from the trained data and also you can do it. Again, you have to go back to your location command and give the row numbers 0 to 8523, like that you have to do, and then you have to do it. But in Python, what is happening is that outer value, if you forget, you will not get the exact rows. So to avoid it, we will add the column to the test data. That way, we can shortly separate the data later. Okay. So what I will do now is, for pre-processing, we will combine both train and test data. We'll combine both the train and test data. And for row concatenation, since number of variables must be equal, we will add dependent variable to test data. We will add the dependent variable to test data. So big mark test, square bracket, single quote, the name of the column should exactly match. So for that purpose, I'm copy pasting from here. Item outlet sales, Control C, Control V is equal to test. So it will add the column in the test data and fill that column with the word test. It will add an extra column in the test data, and that extra column will be filled with the word test. Why I'm doing it? To make the number of columns equal in both the data frames. If the both the columns have equal number of columns or equal number of variables, then we can do concatenation. So I have added the dependent variable item outlet sales to the test data and filled that column with the word test, single value. All the cells in that data frame, data column would be test, 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 it will be filled. Okay. Now we have equal number of columns. So combine df is equal to pd dot concat, open bracket, square brackets, big mart train, comma, big mart test, comma, axis is equal to 0. Now the most important thing is axis is equal to 0 is row concatenation and axis is equal to 1 is column concatenation. So axis is equal to 0 is row concatenation. So what it will do is first it will paste all the rows of big mart train. Below it, it will paste all the rows of big mart test. So up to 8523 will be train data. From 8424 till end would be test data. Okay. So we are combining the data frame into one. Now combine df dot. So we have 14,204 observations with 12 variables. We have combined both the data frames into one single data frame called combined df for the purpose of pre-processing.
Instead of sequential adding, we can go for the randomization.
No, that you should not do now. All right, all of you got this? All right, all of you got this? Right? Combining the data frame into one for doing pre-processing. We will do step-by-step pre-processing. Now, combine df dot columns. Do we have any duplicate columns? This is small data, you can do it by inspection. There are no duplicate columns. There are no duplicate columns. You can just look at them and you can verify there are no duplicate columns. So combine df dot describe. There are no zero value columns because min and max are different. Mean is also different, right? Min and max are different. There are no duplicate column, zero value columns because you can see the min and max are different. All right. Now the third one, we will check for missing values. Combine df dot is null dot sum dot sort underscore values ascending is equal to so combine df dot is null dot sum dot sort underscore values ascending is equal to false. So this is the function for finding out the NAs or missing values. Combine df dot is null brackets dot sum brackets dot sort underscore values ascending is equal to false. So this will help us identify the missing values in our data. So there are missing values in two variables, which is outlet size and item weight. Outlet size and item weight are the two variables that have the missing variables, missing data.
gives the Boolean values, whether the number is specific result in true or false.
Which one?
In the code.
Is null is true or false. Some will be add them and it will sort into ascending values. So is null will give you true or false. Some will add up all the truths. And then sort means you are getting the descending order sort. Highest missing values on top, lowest missing values on the bottom. So is null is a Boolean, true or false, and it sums up the true values. And then we are doing the descending sort so that we can have the highest missing values on top with no missing values at the bottom. All right. Now let us look at our first missing value. Outlet size, generally we know it is a object data, right? Size will be generally in our data. So combined here dot outlet size dot value underscore counts. Drop NA is equal to false, so that it will also displace the NAs. So we have three categories: high, medium, and small. Three types of outlets are there: high value outlets, medium value outlets, and small value outlets. And we have 4016 missing values. We have 4016 missing values. Now, if we add those 4016 to medium, it becomes 8000 something. Here it is becoming a large category, right? That means we are creating a bias in the data. If we add it to small, again, it will also become 8000. It will become a larger category. We are creating a bias. We can't add them to high value category because that's a completely small category. You can't make it a big category. When you are not sure to which category we have to add, then it is better to keep them as missing only. Because if you add them to medium, it becomes 8000. That means you are creating too many medium stores in your data, which might not be the true fact. We can't add them to small because small value stores will increase and they will become dominant category, then it will be a problem. We can't add them to high value stores because it will completely distort the data. So when you are not sure to which category we could add these values, it is better to keep them as missing or not available. So we'll create a new level called missing. We'll create a new level called missing. So combined here dot outlet size is equal to combined here dot outlet size dot fill NA. There is a fill NA function. In that I am giving the word missing. So wherever it sees the missing value, it will impute with the word missing. Actually, I'm creating a new categorical level here because we are doing a manual imputation. We are creating a categorical level. If you are using mice algorithm in R, it will spread this nans based on its analysis into all three categories. But when you're doing it manually, when you are not sure to which category we should add, we will create a new category called missing, and we will keep the values, missing values as missing. Okay, so I'll run the command again, copy paste the command down and run it. Now we have a new category called missing with 4016 values. So remember this, whenever you are not able to make up your mind, then create a new level called missing and keep it as it is. Fill n is a function to fill missing values in Python. Got it? So I'll go up and run the missing value command again. Now you can see all the 4016 missing values are gone. I'm running the is null command again. Now you can see all the missing values are gone. Now we have missing values in item weight. We all know item weight will be numerical. Weight is always numerical. So combine df dot item weight dot describe. Oh, what about the pandas describe? So describe percentiles include exclude. What is this include exclude? Okay, but you can see the number of count is different. Count is 12,000. What is our combined DF count? 14,204, right? 14,204. But if you see here, count is 11,765. That means the missing values are ignored. Now, mean is 12.79, median is 12.60. Mean is 12.79, median is 12.60. Both are closer to each other. So you can either do median imputation or you can do mean imputation, your choice, right? So what shall we do? Shall we do median imputation? So combine df dot item weight is equal to combine df dot item weight dot fill na combine df dot item weight dot median. Fill na combine df dot median. Now I will run the copy paste the command down. We got 14,204 observations. And if I go to the top and run the is null, now all the missing values are gone. So I am doing median imputation. Median imputation, you can type in straight line. For you to see, I am typing in 2 lines, but you can type it in straight line, in single line. So if you want to do mean imputation, dot mean. Median imputation, dot median. Fill in a column median. Uh, Same, instead of median, you just replace it with mean. Mean and what values are getting same? Now you should not do it. You should do it when you have missing values. You have already imputed missing values and you are doing again, then it will be overwriting the data. Okay? You decide at the beginning only whether you want to do it in mean. After imputing, you try to impute again, it will replace the value with mean, na? Single value. It will overwrite the complete data with single value. So you have to re-import the data again and correct it. Now your data got corrupted. Okay. Now, what is the next column? If you go to the top, item identifier. We have a variable called item identifier. Now, let us see what is this item identifier. Combine df dot item identifier dot head. Item identifiers, generally identifiers are alphanumeric. Identifiers are alphanumeric in retail. Sales and retail data, identifiers are alphanumeric. You can see here, they are alphabets and numbers. But if you closely observe, the first two letters might resemble the item codes. If we look at the first two alphabets, they might look like representing a item code. So what I will do is, I'll extract the first two letters from this identifier, create a new column called item code, and store those two letters in that item code. Then I will do the value counts to check how many item codes are there in our data. So then I will delete item identifier later. While going for modeling, I will delete item identifier. I will include item code as the variable. So I will extract item codes from item identifier. It looks as if the first two letters indicate to a item code. So I have to create a new column called item code. So combine df square bracket single quote item underscore code is equal to, I am creating a new column here called item code. Combine df dot item identifier dot apply lambda is an anonymous function space x colon x square bracket 0 colon 2 lambda x colon x square bracket 0 colon 2. Now let me see the new column. Combine df dot item code dot value underscore counts. There are three categories. FD means food. NC means non-consumables like detergent, soap, like that. And DR represents drinks. So I have extracted the first two letters from identifier and I have saved them as a separate column called item code. Now I will delete the item identifier. Item identifier, I will delete it. It's no longer of any use to me. I will use these item codes as our independent variable. I have created a new variable. I have created a new variable called item code, which is the extraction of first two letters of the item identifier, which are indicating to categories. There are three categories: the food, the non-consumables, and the drinks. So based on your subject knowledge, once you look at your identifier and you see there is something going on in the first two letters or first three letters, you can immediately extract them. Lambda is an anonymous function. So what happens here is, you have not done Python. We have not done Python. I only have See, in normal programming language, we have this def, right? Def function, defining a function. Right? You see programming and all, you are all engineering days only, right? Def, I will name this function as add, colon. What is add? Add is equal to x plus y, return, right? This is the simple thing, right? It is called a function with a name. We are creating a function called add and we are naming. Lambda is anonymous functions. Anonymous functions means without name. Without name. These functions will be same like df but without name. So lambda space add colon x plus y. Simple. Instead of defining a function, you will use anonymous functions. The word lambda indicates no name. Lambda, and then you give the same argument. Whatever you give this argument, you give the same. Okay. So lambda functions are anonymous functions in Python. You don't need to give a function name. Otherwise, in normal function programming, you have to write def function name, colon, then you give a argument, and then based on the argument, you will get the return. So this is the difference between a normal function and a lambda function. Okay. I can see a lot of examples online also. See here, lambda is the keyword, x bound variable, comma bound, colon bound. This is the keyword lambda, keyword and that one. So this is the comparison. So lambda x colon x plus 3 versus df add 3 in bracket x colon return x plus 3. So if you are using normal function, you have to write like this. Anonymous means x colon x plus 3. That is the difference between a lambda function and a normal function.
Only arithmetic functions.
No, we have done our formatting function now. This is not arithmetic, right? Slicing a text. It's a formatting function. Na? What we have done here is not an arithmetic, right? What we have done here is not arithmetic. It's a slicing function of a text value. So you can do arithmetic functions, you can do formatting functions, slicing functions. So all those things. So lambda means that is the context of lambda. Let me move it to the upper thing so that you can easily understand what lambda is all about. So understood, right? So lambda functions are anonymous functions. You don't need to give them a name. Whereas in your normal programming language, whenever you are writing a function, def function name, then the data reference colon, and then the return argument x plus 3. Same thing, you just write it within lambda x colon x plus 3. Simple. Both will give you the same output. Clear, participants? All of you got this? Yeah. Shall we move? Now, the next variable, if you go to top, item weight, we have already imputed the missing values, nothing there. Now, let us look at item fat content. Let us look at item fat content. Combine df dot item fat content dot value underscore counts. So if you have done D types in earlier, you will know, right? Object and things. So you can do D types and you can find out also what is the type of data we are dealing with. So if you are not sure what to do with what, after this, you can add combine df dot D types. In D types, I came to know item fat content is object. Item fat content is object. That is why I have run value underscore counts. Now, what is the problem here? That we will do before modeling. Now we should not do anything. We should not do, because it's a combined data. We will, deletion of variable will be before beginning of the model. Before beginning of the model, then you will either do before splitting the data, or after splitting the data, you will do separately in train and test. That situation will be later. Feature selection will be end after pre-processing. Okay. Now we will not touch anything because it's a combined data frame. We don't want to do anything. We will do that after everything is over. Then we will decide which variables to drop, how to drop, and all those things we will decide. Okay. Now, fat content. What is the problem here? Duplicate levels. Levels have been duplicated. Actually, there are only two levels: low fat and LF, regular. But because of the data input and errors, we have created duplicate levels. Okay, now we need to merge these levels into one. We have to merge them into one. Now, so what we can do is we can do v dot sub is there. So we will use regular expressions to submit, right? Substitute. Import or I did directly. I am using this. 1 second, let me check. Replace is there. We don't need to do anything. We'll use replace. Yeah. Combine df dot item fat content is equal to combine df dot item fat content dot replace open bracket within square brackets. Will give both the arguments lf comma single quotes low fat. We will replace it with what? Single quote low fat, F capital and L capital. So combine df dot item underscore fat content is equal to combine df dot item fat content dot replace open bracket multiple arguments. You have to give it in square bracket as array. LF and low fat will be replaced with low fat. Similarly, combine df dot item fat content is equal to combine df dot item fat content dot replace. It's a simple thing here. We have only one argument, reg comma regular, reg comma regular. Now I'll go to the top and I'll run the command again, or I'll copy this down to check what is the impact. I will do it now. Now we have combined them into two categories as the case should be. Replace, pattern replacement. All right. So what is the next variable? Item visibility. So type of item visibility is float. So then we'll do describe. Combine df dot item visibility dot describe. So in item visibility, if you see, minimum is 0. Sometimes if a column has too many zeros, then it will create a problem. So let us check how many values are 0 in this column to make sure that there are too many zeros in that particular column. If a particular column has too many zeros, it might create problem in the algorithm and it will be downgraded in the algorithm. But item visibility is a very critical factor, right? For a sales, visibility is a critical factor. We cannot allow that variable to be downgraded. So let us check how many zero cells are there in that particular variable. Okay. So let us say, I will name it just a zero visible is equal to combine df square bracket combine df dot item visibility double equals to 0. So we have to count how many rows are 0. So we can simply say 0 visible dot shape. Oh, tuple object is not callable. Why it is saying tuple object not callable 0? We have separated it. Not value counts. We need to know how many rows are there. Shape, that's what I did. Shape should give us that, right? I don't know why. I might have put a brackets earlier. So we have 879 rows that are 0. 879 rows are 0. 879 by 14,204, I think it is less than 1%, right? It's very few. Or you can divide it also. 879 divided by 14,204. 5% or 6%. 6% or has 0 columns, that's not a big deal. If it is more than 10% or if it is 20 to 30%, then we might have to look at the visibility factor. Now it is very less single digit, so we should not bother about the visibility factor. Got it, all of you? What is the next variable? Next variable? Combine DF. What is the structure? Is it a float or object? Object. That means value counts. Dot value counts. Item type dot value counts. So we have different types of food products: fruits and vegetables, snacks, household, frozen, dairy, baking, canned. So I think there are not much of a levels. Simple levels are there. We can keep item type as it is. We don't need to do any change to this variable. Already others is there. Small categories have been combined into others. And we have hardly less than how many categories? 20 categories are there. So it's not a problem for us. So item type, no need to be done. What is the next variable? Item MRP. I think it should be float, right? Dot item MRP, maximum retail price. Dot describe. But so item MRP, there is no problem, right? So all the, there is no missing values, nothing. Minimum is 31, maximum is 266. So we don't have any problem with this item MRP. Mean, median are also closer, 141 and 142. What is the next variable? Object or object? So different outlet identifiers are there from starting. Outlet 10, 13, 17, 19, 18, 27, 45, 46. We don't have anything to do here. We'll keep as it is, outlet identifiers. Next variable. What is the next variable? Outlet establishment year. Now we have year. When the year, in which year the outlet was established. Generally, years, dates, we generally tend to extract information and we tend to delete them. Now, here we can do one thing. We can calculate the outlet age as of year 2020. Based on the establishment year and as of 2020, what is the outlet age? Or 2021. As of 2021, what is the outlet age? So we can simply find the outlet, we can create a new variable called outlet age, which will be deduction of outlet establishment year from 2021, and we will know how many years the outlet is old. Then we can delete the establishment year and we can keep the outlet age. So let us create a new variable called outlet age. Combine df square bracket single quote outlet underscore age. Sorry, outlet underscore age. This is a new variable I am creating. 2021 minus combine df dot outlet establishment year. A new variable is created called outlet age in years based on the deduction of the year establishment year from as of 2021. So we have created a numeric variable. Combine df dot outlet age dot describe. So we have minimum outlet age as 12 years, maximum outlet age as 36 years. So age of the outlet in years from establishment day year to as of 2021, we are counting the years. So minimum outlet age is 12 years, maximum outlet age is 36 years. Now we can drop establishment year. Instead of establishment year, we will take the age variable. So two variables you have to drop when you're building the model, which is identifier and establishment year, because we have created new variables from them, right? So we will remove the old variables from our data. Got it? Creation of new variables based on your existing variables. You can create like this so that you can understand what we are exactly doing. हेलो हाँ हाँ, ये थर्ड फ्लोर में आके रिसेप्शन में दे दो, रिसेप्शन में दे दो। राजेश बोलो, रिसेप्शन में दे दो। Okay. So what is the next variable? After establishment here, what was the variable? Location, outlets, location type. Size we have already corrected. Outlet, location type, dot value counts, because it's object, value underscore counts. Tier 1, Tier 2, Tier 3. Three location types are there. Nothing to be done here. Tier 1 cities, Tier 2 cities, and Tier 3 cities. What is the next variable? After outlet location type, the next variable is outlet type. Dot value underscore counts. Supermarket type 1, supermarket type 2, supermarket type 3, grocery store. Nothing to be done here also. So we have done broadly with our variable pre-processing. We have done our variable pre-processing as of now. Now, what we have to do, we have to look at data transformations. What is the structure of our independent variables? Are they in different mathematical units? Should we scale them or not? Then we have to check our dependent variable, but we will, after separating the data into train and test, we will check our dependent variable for skewness. The histogram, box plot, and density plot must be done on item outlet sales. That can be done only after separating the data from combined to train and test. Okay. So just let us look at our data, how it looks like. Combined df dot head 3. So I'll just take 3 rows. So the label encoding is there. Now we have to do label encoding also, right? We have to do label encoding. Then only our pre-processing will complete. Label encoding means text has to be converted to numbers. Right? All the text categorizations should be converted to numbers. Okay. So we'll do it in the next session because it's already 1 o'clock. So we have to split the data frame into 2. So that we will do now. Numeric calls is equal to combine df dot select underscore d types include is equal to np dot number. Object calls is equal to combine df dot select underscore d types include is equal to square bracket single quote object. Print numeric calls dot shape. Print object calls dot shape. So we have 5 numeric columns, 9 object columns. Okay, but in object columns we also have item outlet cells. We have to be very careful. That should not be there. So we have to remove item outlet cells. Why it is coming in object? Because half of the data is numbers, the other half is test, the value test. So it is coming as object. It will come as object. If you see here, object calls dot columns, you can see item outlet sales is also here because half of the data is test, right? Test word. So we have to remove it and then we have to label encode it. We have to remove identifier, we have to remove outlet sales, and then we will label and encode the rest of the variables. Okay, we will add item outlet sales back to numeric calls and delete it from object calls. Then we will also drop the item identifier. Then we will run the dummy get underscore dummies, or we can do label encoding, whatever is there. We will do both the processes to understand the impact on the model. And then we will do the, if needed, if we need a transformation, and then we will conduct the model. Clear? So to some extent, we have completed our data pre-processing. Oh, it has saved as for long file. Review 10 pages. All right, I have sent it to your group, Google Groups. You can take it from there. Okay.